I would like to welcome you all in the lecture series of power electronics. In this video, I am going to discuss the operation of type E chopper. Type E chopper is also known as class E chopper. Basically, type E chopper operates in four quadrant. Therefore, this is also known as a multi-quadrant chopper. So, if I plot a Cartesian plane, like the y-axis, it is basically voltage and x-axis is current, then we can say the operation of chopper in the four quadrant, that is voltage current plane. Now I would like to introduce different operations in four quadrant. When it comes to the first quadrant, the operation is known as forward motoring. In the case of forward motoring, positive voltage and current, that means output voltage and current will be positive. So motor runs in the forward direction. That's a peculiarity of the first quadrant operation. While we inspect second quadrant operation, this is known as forward braking. Here, like a motor brakes while still running in the forward direction. That means it's just opposite to that of forward motoring. So what are the peculiarity? Here, this is basically, we can say voltage is positive, but current is negative. That means the voltage is getting positive like a positive direction where current is in the reverse direction. Therefore, motor is going to be stopped. This is known as forward braking. Whenever we are considering the third quadrant, that is known as reverse motoring. That means motor runs in the reverse direction. In the first case, first quadrant, what happened is motor is running in the forward direction, where in the third quadrant operation, motor is running in the reverse direction. So both the current and voltage are negative in this particular third quadrant operation. While coming to the fourth quadrant operation, this is known as reverse braking. While we consider reverse braking, the voltage is in the negative direction, where current is positive. The opposite, the peculiarity is motor brakes while running in the reverse. It is just opposite to that of what we can say the third quadrant operation. So motor brakes while running in the reverse direction. There are few applications, especially electric vehicle drives. We are using the Type E chopper. Then DC motor control for robotics. Like some cases, there will be like a forward direction. Immediately it has to be stopped, then reverse direction, again stopping. So such kind of operation, it is better to go for like a Type E chopper only. Why? Because it is a multi-quadrant operation. We require such cases like robotics and all. When it comes to industrial drive system, and we require both motoring and regenerative braking, both are required. Okay, these are the few applications which are most commonly used in industries. Now we would like to have a brief discussion about the working of Type E chopper. First of all, I would like to introduce the circuit diagram of the Type E chopper. So we have a DC supply, and as you can see, we have four power electronic switches, which is made up of IGBT or MOSFET. So we have S1, then S4, then S3, S2. Apart from that, we have the freewheeling diode D1, D2, then D3, D4. And what about the load? We have RLE load, which is generally called DC motor load. Okay, so these are the basic components which you can observe in the circuit diagram. How does it work? As you can see, there are four cases. So first, I would like to introduce the first case. Remember that two switches are operating at a time simultaneously. Don't think that like one switch is like S1 is on, then S4 will be on. It's not like this. Remember, S1 and S4 both are operating simultaneously. In the sense, S1 and S2, S4 are turning on together. Say as in the in the opposite direction, S1 and S2, S4 will be turned off automatically. I mean, simultaneously. Correct. Yeah. So S1 and S2 are turning on simultaneously. So now what we can see, S1 and S4 will be turned on simultaneously. Now what about the current direction? Of course, current will be starting from the supply. Okay. So now it will be directly passing through the load. Hope it is very clear to you. And there is a resistor, then inductor. Okay. Resistor that will oppose the movement of current flow. That's correct. But if I talk about the inductor, it's an energy storage element. So inductor keep on getting charged from the like a current which is provided from the supply. And this is actually called the back EMF. Okay, now it will be moving in this direction. Okay, finally, what is going to happen? This will come back to the negative n direction. So, in the examination, you can mark the direction of current in this particular direction. Okay, particular fashion. It is pretty clear that both output current, so output current and voltage both are in the same direction. Moreover, both are in the positive direction only. So V naught and I naught will be positive, correct? So therefore, we can categorize this particular operation into first quadrant. Therefore, voltage and current will be positive. Okay, the peculiarity is inductor is getting charged. Okay, it will keep on charging, and finally it will store energy from the magnetic field. So inductor is getting charged, the output current and voltage are positive. Therefore, we can mark this operation in the first quadrant. So polarity of inductor will be like a plus minus in this direction because it is getting charged, right? Yeah. So now we'll see another case. S1 and S4 will be turned off simultaneously or at a time. Together we are turning off S1 and S4. So remember that inductor is like uh, already inductor is charged. Immediately, if it is turning on means inductor is getting discharged. Whatever the energy which is stored in the inductor, that is getting dissipated or discharged. We can say like this. So dissipation in the sense this become positive and this is negative. Correct? Yeah. Now the thing is how check the inductor it will dissipate energy. Okay. Now the thing is, what about the current and voltage? The direction of current and voltage. Remember, inductor polarity is getting reversed. So here, inductor release the energy. The output voltage become negative, where output current become positive. Okay, output current is getting positive because both are in the same direction. Where the output voltage. What about output voltage? Output voltage become negative. Okay, that's a speciality. Now we can say it is going to operate in the fourth quadrant. That means the diode D2 and D3 is getting conductive. Diode D2 and D3. Where is diode D2? Yes, this is diode D2 and we have diode D3. How it is getting conducted? I'll tell you one thing. So inductor polarity. See, polarity is getting reversed. Correct, no? Polarity is getting reversed. So the current flow will be always from like a positive to negative, correct? No. So what is going to happen? The diode D2 and the D3 that is getting conductive. Okay. Now I would like to discuss about the third case. In the third case, S3, S2 and S3 are turned on simultaneously. So let us come back to the diagram. So what I'm going to do is S2 and S3 will be turned on simultaneously. Okay. So here, what about the current flow? So current flow will be in this direction, positive. Then it is directly moving on to the switch S3. That means IGBT, correct? Yeah. So now you can see the direction of current. This will pass in this particular direction. And finally, it will come back to S2. Then it will be reaching to the negative of the supply. So this is the way how the current is moving whenever the switches S2 and S3 are getting operated simultaneously. Okay, you can mark the direction of current. Here, what are the speciality? Of course, the inductor is getting charged, of course, correct, no? So inductor polarity will be like this only. Inductor polarity will be positive, negative like this only. Okay, the inductor is getting charged. Okay, that's a speciality which you can observe if two switches are turned on at a time, correct? Yeah. Now I wanted to explain what are the changes which are happening in the circuit diagram. Okay. Here we can say like S2 and S3 and S2 are simultaneously. Output current and voltage are both are negative only. See, output voltage and current both are in the negative direction. Okay. Because see the polarity that will be in the reverse direction only. If I talk about output voltage, that is also in the inverted manner. V naught and I naught will be negative. So it will obviously work in the third quadrant. Okay, third quadrant will be just opposite to that of first quadrant. The third quadrant, both current and voltage are in the negative direction. Okay. Now we'll be inspecting the last case. In the last case, whatever the switches which are turned on, that will turned off simultaneously. Okay, we are going to turn off simultaneously. Okay, so here inductor polarity was like case three, positive should come here, negative should come here. Now inductor polarity is getting reversed. Okay, so that is another speciality which you can observe. Polarity of inductor is getting reversed. Ultimately, the thing is inductor releases the energy, output voltage become positive, where output current is getting negative. Okay, so by combining all the four cases, we have like a, four quadrant operation. Okay, so we can mark four quadrant operation in this diagram. The hatched portion means the operating region, correct? So with respect to different operating region, so we can categorize like what about the polarity of voltage and current. Okay, so we can predict the further operations. So major application is electrical drives, especially in electric vehicle EV systems. Okay, we require like a driver part. So we will be usually using the type E chopper or class E chopper. So parallelly, you can plan for like a conduction of workshop or demonstrating the hardware kit, etc., so that you'll have a better knowledge. Even software also you can do the simulation. I'll be coming up few more videos about the software, so that especially in the MATLAB, so that you can develop the coding appropriately. Let me know if you have any queries related to the type E chopper. I'm happy to answer. You can use the comment box so that we can communicate each other. So thank you very much for watching this video. I found this is one of the most important questions, especially for the competitive examination. So while preparing for the competition, just pause and identify. Okay. Thank you very much for watching this video. Happy learning. I wish you all the very best for your forthcoming exam.